Okay, so this is chapter one. This chapter is actually gonna be pretty easy, and the thing is that I didn't have any more reviews, so I'm gonna go chapter by chapter what's on the test, just so you know. And this should be going piece by piece through what we've actually learned so far. Now, the first chapter was the Pythagorean theorem. Most of you guys should have been able to do this by now, but let me go over this. So you're always going to be given a right triangle. When we're dealing with Pythagorean theorem, that means you are dealing with the right triangle. Alright? So, what you're always going to have to do is you're going to be given one of two options. You're either going to have one that looks like this, where we have a number like 9, and let's call this 16. No, they're not going to do 16. Let's do, I don't know, 21. Where we need to find our hypotenuse, or we're going to be given our hypotenuse like in, I don't know, 200 or 20, and that's 10. Okay? In this one, the hypotenuse is given, and you have to find one of the sides. In this one, the two sides are given, and you have to find the hypotenuse. In both cases, you are still trying to reduce the radical when we're finished. So this is what we do first. We label our sides, because remember, when we're talking about the Pythagorean theorem, we're talking about a squared plus b squared equals c squared. And now remember, and so we have a and b are our legs. And these are interchangeable. A could be here, B could be here. It doesn't actually matter what answers where, because A and B is interchangeable. The only thing that's not interchangeable is the C. It is always across from that right angle. So, in this first one, we're going to label this A, we're going to label this B, we're going to label this C. C is always your hypotenuse, and so that's what we're missing right here. So, I'm going to start off with a squared. I actually have a number for a, and that is 9, so I'm going to put 9 squared. I do not have a number for b, so I have to put b. Actually, I'm sorry, I do have a number. It's 21 squared. But I do not have the c, so I have to put c squared. So 9 squared means 9 times 9, which gives me 81. 21 squared means 21 times 21, which gives me 441. And that's going to equal c squared. Alright, next step. Add these two things together. Well, 81 plus 441 gives me 522. And we still have this equal to c squared. So what I have to do now is try to get c by itself. In order to get c by itself, I have to do the opposite of what is a squared term, which is called the square root. So I square root this side, and I square root this side. Now when you put the square root of 522 in your calculator, you get this really long decimal. And we can't deal with this decimal. We don't want to deal with the decimal. So we do what's known as reducing the radical. So you're not done when you're here. Alright? This does give you c, but we're not finished yet. Now we have to break down this 522. So first, I know that this is divisible by 2. So when I put my calculator 522 divisible by 2, I get 2 and 261. Now when I break this down, I get 3 and 87. You have to keep just trying to figure out what numbers can go into here by taking this and dividing it by random numbers just to see what it's divisible by. In this case, 3 and 87 will give me 261. And finally, if I divide this by 3, I get 3 and 29. And so I've broken down this thing into its base, prime, numbers. 2, 3, 3, and 29. So what I'm going to do is I'm going to rewrite it right here. 2 times 3 times 3 times 29. Okay. If I take all these and multiply them together, I end up with 522. Our next step is to actually pair up the numbers that are the same. So in this case, this number is the same. We have a 3 and a 3. 29 doesn't have a pair. 2 doesn't have a pair, and 29 does not have a pair. So all we can do is deal with these 3's. Now, technically what we're doing is we're taking these 3's and we're doing the square root of whatever 3 times 3 is. Or the simplified method, we just take the 3's and they come out of the square root as a single 3. Alright? Then I'm going to put under the square root what's remaining. I have a 2, I have a times, and I have a 29. So 2 times 29 gives me 58. So my reduced radical form is 3 square root 58. Okay. Now what happens if we have one where it's the hypotenuse? Well, I'm going to go A, B, C again. Alright? This time I don't know my A squared, so I'm just going to put A squared down. I do know my B squared, that's 10 squared, and I do know my C squared, which is 220 squared. From there, I just got to square my numbers. Plus 100 equals 400, because remember, this is 20 times 20, this is 10 times 10. A squared is just brought down. Then I need to get A squared by itself by subtracting 100. Gives me A squared equals 300. My final step is to square root, and if I put that in my calculator, I'm going to get a decimal. So what I got to do is I got to break down 300. So that comes down to 30 and 10. This breaks down to 3 and 10. This breaks down into 5 and 2. This breaks down into 5 and 2. So what I'm going to do is rewrite these out as 3 times 5 times 2 times 5 times 2. And now I have to match up my pairs. I have one pair with these 5's, one pair with these 2's, and I have a little 3 left over. Well, when we have a pair, remember, they come out as a single number. You have a second pair, comes out as a single number. And this 3 doesn't have anything to go with, so it goes back under the square root. Now, since these are both coming out, they actually have to multiply. So like 5 times 2 gives me 10. So my answer would be 10 square root 3. And that's how you reduce the radical with the Pythagorean theorem. Now, the other part of this chapter that we went through in here is the A squared plus B squared equals C squared. A squared plus B squared is greater than C squared. A squared plus B squared is less than C squared. Okay? This is called the Pythagorean converse. The reason is that we're going to try to figure out what type of triangles these things are, whether they're right, which means that it's equal to, whether they're acute, which is greater than, or obtuse, which is less than. So you'll see little triangles like this. Alright, they'll be facing different directions, doesn't really matter. So let's say this is 20, this is 15, and this is 4. Your C is always going to be your longest side. Since we don't have a hypotenuse in this case, we're just going to call whatever's our longest side C. Our A and B do not matter. You just need to label them A and B, the remaining two sides. This is where we start. A squared is 15 squared. B squared is 4 squared. We don't know whether this is going to be greater than, less than, or equal to yet, so I'm just going to put this line right here. Last but not least, we're going to have 20 squared. So we know 15 squared is 225. We know 4 squared is 16. And then we know 20 squared is 400. Oh shoot, that's not supposed to be second squared. Then we add these two numbers together, which is 241. And then we have 400 over here. So our last step is to figure out which side is bigger, or are they equal? Well, I know 400 is bigger than 241, so I'm going to make a little thing like that. At this point, I'm going to go back up to the top. So we're going to look at the same symbol. Where's this symbol which means less than? Well, it's part of the obtuse triangle. So I know this triangle, based off its measurements, is obtuse. Alright, I'm going to do one more just to show you. This is not always going to be the spot where the C is. Let's say I put the C, you know what, I'm just going to put it right here. Let's do 28, let's do 23, and let's do 18. So, this problem right here, our C once again is the bigger side. So I'm going to make this the C. The A and the B once again do not matter. These are interchangeable. They do not matter where they go. But we're going to figure this out now. We're going to start with 18 squared plus 23 squared. Put that line there because once again I don't know what's going on yet, so I'm going to put that squared. Start with 18 squared. 18 squared is going to give me 324 plus 23 squared gives me 529, and then 28 squared gives me 784. So when I add these two together, I get 853, and this side is 784. Once again, we put the mouth to the bigger side. We know this side's bigger. Therefore, you automatically know that this is going to be an acute triangle. Alright? That's all that we have from chapter 1. Or chapter, sorry, whatever the Pythagorean theorem chapter is. And move on to the next video.